Hi, my name is Marcio, and I'm studying the evolution of estuaries over long time scales with morphodynamic models. Geological reconstructions tell us the story of preserved sediment and features, or at least as much as sand and mud can tell us. But erosional records, as well as the physical process underlying those deposits, are commonly of large debate and uncertainty. So my research focused on bridging the gap of knowledge between geologists and engineers. Here I use process-based models to unravel physical process and isolate the effects of initial, boundary, and internal conditions that determine the large-scale evolution of estuaries. As part of my project, I'm working on improving the prediction of wave-related sediment transport in numerical models, in this case Delft3D, over long time scales. Wave-related transport is usually simplified or neglected on such long time scales in both geological and coastal engineering community. Nonetheless, the waves are an important driver in shaping coastal environments. In addition, I'm studying the influence of fluvial and tidal boundary conditions in building the landscape and in filling the accommodation space. This project includes a novel numerical study of fluvial tidal levees in addition of including the effects of vegetation or morphodynamics. And those models were inspired by the old Rhine estuary case in the Netherlands, but also in worldwide studied levees. With this model advances, I'm interested in the full interaction of all aforementioned elements: waves, tides, rivers, sea level rise, sand, mud, and vegetation, and how they act together to build the land. And why we are doing such complex simulations? Our main question is how some deltas like the Netherlands naturally build up land during the Holocene under sea level rise, and how those low-lying land areas can cope with sea level rise in the future. With this knowledge, we can improve our understanding of long-term evolution of complex coastal systems that includes important ecosystems and the safety of large portion of the population. We are also improving the reliability of numerical modeling that are largely applied to hindcast and forecast alternative scenarios, as well as guide the present and future actions to manage coastal areas in a more sustainable and naturally friendly way.